Hello everyone, for this tutorial video I'd like to explain how to figure out the curvature or rate of change of the rate of change of a vector function. Formally defined, the curvature is defined with a k-like symbol called kappa, and this equals the magnitude of the change in the unit tangent over the change in arc length. But we remember that getting the vector in terms of its arc length is sometimes a difficult process. So we can see that there are two different formulas for curvature that do not involve changing the parameter to be relative to the arc length, like this. We have curvature equals the derivative of the unit tangent over the derivative of the vector itself, or more specifically, the magnitudes of these, which makes sense from what we have proven in the previous videos. But there's actually a second, more obscure definition, which is the numerator is the magnitude of the cross product of the first and second derivative of the original function over the magnitude of the first derivative cubed. Using our function from the previous video and our discussion of arc length, we remember we already found an equation for t in terms of arc length, so we plug this in. We now take the derivative of the unit tangent, compute the magnitudes as warranted, and see, after we write this ratio out, we get a final answer of 3/10 for the curvature. We can see that this constant answer makes sense, because if you graph out the function, you get a helix shape, which has a constant curve all around it. Now that we have figured out how to find the curvature or concavity of a vector function, we can discuss cylindrical and spherical coordinates next, which are essentially 3D-ified version of polar coordinates. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.